Welcome to another edition of CEC Gurukul lectures. Today we are going to discuss the basic concepts of operational amplifiers. Now, what are operational amplifiers? As the name suggests, operational amplifiers are those amplifiers which are designed to perform different mathematical operations. Now, we understand from amplifiers that they amplify the input and give us a higher magnitude output. The input can be a voltage, input can be a current, or input can be a voltage and current together in the form of power. And where do we see these amplifiers? We see these amplifiers in everyday lives. For example, when we have a DJ playing music at a high decibel, that is a power amplifier. When we have a lift, then in the lift it is written that maybe 8 persons or 1080 kg. So how does the lift understand that, okay, there are 8 people, or rather 1080 kg is allowed? It is via the operational amplifiers, because operational amplifier allows us to add up individual amplified factors. When we use a microwave, it has certain custom cook operations inbuilt. Those are achieved using operational amplifiers. A washing machine, a smart washing machine that we have, it is, suppose a washing machine is rated for 8 kilos. So how does it know? It is an inanimate object. How does the inanimate object know that 8 kilos of clothes, wet with water, including the water, weight of the water also, is total 8 kilos. How does it know that it is already 8 kilos? Above 8 kilos, it doesn't work. This is all achieved by means of these operational amplifiers. Operational amplifiers typically help us in addition, multiplication, integration, subtraction, division, differentiation. So, how does operational amplifier look like? In the screen, the basic operational amplifier that we are going to discuss is the 741. It is an analog integrated circuit, and the important thing to note over here is that, of course, it has only one output, but it has two inputs. One input is designated as a minus, which is pin number 2 of the integrated circuit, and one is designated as the plus, which is pin number 3 in the integrated circuit. What do these signify? Also, we have a power supply that is associated, the fourth pin number 4 and pin number 7. This IC operates on a dual power supply. This operational amplifier works on a dual power supply of plus minus 15 volts. Now, concentrating on the inputs. This operational amplifier amplifies the difference of the input, that is pin number 2 and pin number 3. The minus sign over here signifies that if an input is given to the minus input, that is pin number 2, the output will be out of phase by 180 degree. Whereas if the input is given to the plus, then, or pin number 3, then output and input would be in phase or 360 degree out of phase. Now, depending on the strength of the signal, the output can be in phase or out of phase. That means, let us say if we put a 5 volt input to pin number 2, the minus one, and 3 volts are provided to the plus input, that is pin number 3, then the output would be the amplification factor into 5 minus 3, that is 2 volt, and the input would be out of phase with the output by 180 degree. If the roles are reversed, that is, we provide 3 volts to the negative input and 5 volts to the positive input, then output would be 2 volt into the amplification factor of the operational amplifier, and input and output would be in phase. Now, what are the characteristics of this operational amplifier? This operational amplifier is a direct coupled high gain amplifier. Direct coupled means it can be used in a modular manner. High gain, yes, it has a very high gain, and typically in open loop configuration it gives a gain of 2 lakh. Of course, it is unstable at that point of time, and it is of practically no value unless used as a switch. So we use this amplifier in closed loop configuration only. In op-amp, it's a versatile device because it is able to process both DC as well as AC signals. Typically, it performs mathematical functions, like I said, including addition, subtraction, integration and differentiation. And it has a lot of applications, including signal amplification. It is used in active filters. It is used as an oscillators as well as in regulators. As we will see later, this op-amp also finds applications in conjunction with digital circuits for taking important decisions. So basically, this amplifier is used only for mathematical operations and helps induce the component of AI, artificial intelligence, in electronics. The typical pinout diagram of the operational amplifier is shown over here, and we see pin number 2 is the inverting terminal, pin number 3 is the non-inverting terminal, pin number 6 is the output, pin number 4 and 7 are the power supplies, pin number 8 is no connection and is left floating. Pin number 1 and 5 are meant for offset. Now, what is offset voltage? We all know that these integrated circuits are built with semiconductor components. Now, semiconductor components have a typical drawback, and which is that they show different levels of conductivity as a function of temperature. At higher temperature, they conduct to a higher level compared to low temperatures. Now, in this slide also is shown the power supply connections of the operational amplifier, and we can see that pin number 4 and pin number 7 are connected to the dual power supply, wherein pin number 7 is plus 15 and pin number 4 is minus 15. The ground is in between, and two power supplies are joined together to realize the functioning of the same. So, what is operational amplifier? Operational amplifier amplifies the difference of its inputs. That is the bottom line. So, what are the characteristics of an ideal operational amplifier? For an ideal operational amplifier, we should understand that it never exists in practical life, but of course it can be assumed to exist as part of theory. So, what is the first expectation or first characteristic of an ideal op-amp? Number 1, it should have infinite voltage gain, and as is shown in the slide, AOL, A is the symbol for voltage gain, OL stands for open loop. So, AOL should be equal to infinity, and for this the differential voltage that is VD, between the two inputs 2 and 3 should be as small as possible. Of course, for this op amp, we should have infinite input resistance. Why should the input resistance be infinite? It should be infinite for any ideal amplifier, because then it will not lead to loading of the previous circuit. Now what does it mean? It means that when we use amplifiers, they were never used in a single stage. We always have a cascade mode or modular addition of amplifiers. So when two amplifiers are connected to one to another, they are in parallel combination. So when anywhere we have parallel combination of a resistance or impedance, we know that the parallel combination of any number of impedances, any number of resistances leads to the equivalent impedance or resistance which has a value which is smaller than the smallest. So if we have a very low input resistance, then when we attach the previous amplifier to the next amplifier, then a parallel combination would lead to a very small resistance, since the next amplifier has a very small resistance, and therefore in this case we are talking only about input resistance or input impedance. So in this case it will lead to loading of the previous stage in the manner that it has to supply more current than it is designed for, and this parallel loading is the cause of short circuit in all the cases. Whenever we have a short circuit, we see that a huge amount of current flows through the circuit, mainly because of bad designing and choices. So whenever we say there is shorting of the circuit, it actually means that the circuit is supplying more current than it is designed for. So hence an infinite input resistance is the basic requirement of any ideal operational amplifier. As we have discussed the case of input resistance, we also discuss that the output resistance of the op amp should be 0. Why should it be 0? So that maximum amount of current flows through the output circuit. It is always the output of the circuit that drives other devices. A typical thing that we had already discussed in our digital lectures, there is a terminology called fan out. That fan out decides that a particular how many devices is being driven by the IC. Fan out of the IC is a data that is provided by the manufacturer. Likewise, fan in and also the data provided by the manufacturer of the integrated circuit. Hence, input resistance and output resistance work in tandem in any type of amplifier. Another requirement that is necessary for op amp to be ideal is that there should be zero output voltage when input are both the inputs, that is number 2 and number 3 pins, are grounded. That is, when input is 0, the output should also be 0. Although this is defined only for the ideal case, because in real life, as we discussed earlier, we have the case of semiconductors and circuits are not always balanced, as a result of which even when we have 0 inputs, we have some level of output in this IC, or in the case of operational amplifier. Now before we jump to conclusions, it is important to note that we are always dealing with two kinds of voltages in the operational amplifier. If we go back a couple of slides, we find that in this case the diagram shows that operational amplifier is driven by a DC power source and it is able to amplify the voltages at its input. That can be either a DC voltage or it can be an AC voltage. So in this case, what we have is that when we have the inputs, that is 0.2 and 0.3 connected to the ground, and yet we have some voltage from the output, then it is safe to assume and understand that we have not created any energy, thus violating the basic principles of physics, or rather we are seeing this output because of the dual power supply, which is biasing the internal components. So going back to the characteristics, at number 0.5 says that ideal op amp should have infinite bandwidth. Now what does bandwidth mean? Bandwidth means the range of frequencies over which the amplifier gives a robust response. So in this case, we have that the ideal op amp should be able to amplify signals from 0 Hz to infinite Hz without any attenuation or distortion of the signal. Point number 6 says that it should have infinite CMRR, that is common mode rejection ratio, where in this case in CMRR we see that we give a common mode voltage to the inputs, and that common mode voltage should be passed as it is through the op amp. At point number 7, we have that ideal op amp should have infinite slew rate. And what is slew rate? Slew rate actually gives an idea about the speed at which the output is able to change as the input changes. Now, the problem is that the op amp is expected to give a robust value of amplified voltage for all types of frequencies. This is theoretically possible, but practically it is not possible, because practically it is seen that the voltage, the amplification factor, tends to drop at very low and very high frequencies. Hence, the concept of infinite slew rate is a bit of distraction in this case. So, but for an ideal op amp, it is expected that it has an infinite slew rate and output changes instantaneously for a voltage with a frequency of, let us say, 10 Hz compared to a voltage, input voltage having 1 GHz as its frequency. So it is expected that the ideal op amp would behave in the same manner for both the inputs, but that is not the real case in practical circuits. Now, the actual op amp is not ideal at any point of time, although it has a very high input resistance, higher order of mega ohms as input resistance. Also, it has a very low output resistance, yet it has a finite bandwidth. So the learning would be based on different types of configurations for the op amp. Now, op amp has 3 types of configuration. One is the open loop configuration, one is known as the closed loop configuration. For these 2 configurations, we will discuss the characteristics of the op amp for 3 different cases. One as a differential amplifier, one as an inverting amplifier, and one as non-inverting amplifier. Now, what is open loop configuration? Open loop configuration of the op amp refers to the configuration of op amp wherein no feedback is provided. This means that point number 6, output 6, is not connected to either input 2 or input 3. When there is no connection between point number 6, pin number 6 and pin number 2 or 3, then it is known as open loop configuration. In open loop configuration, the op amp is seen to exhibit a very, very high amplification factor, which is typically of the order of 2 into 10 to the power 5. With this high amplification, the signal levels tend to develop lot of noise, and effectively this amplifier is used only as a switch, as it moves from a saturation value of current to zero current values. When we fix the point number 3, that is input at pin number 3 to the ground, and we provide input only to pin number 2 of the IC, then the configuration is known as the inverting amplifier configuration. This simply means that input and output are out of phase by 180 degree. Non-inverting amplifier is the complement of inverting amplifier. In non-inverting amplifier configuration, we ground out pin number 2 and provide the input signal to pin number 3. Finally, we measure the output at pin number 6. So under open loop configuration, the output, since the input value is of the order of 2 into 10 to the power 5, the amplification factor is 2 into 10 to the power 5. Hence, even a millivolt input, that is difference in the voltages between pin number 2 and pin number 3 is of the order of millivolt, would give rise to the output in hundreds of volts. Now this is something which is highly unstable. Hence, we use the open loop configuration of the op amp only for flow of saturation current or flow of zero current. That is, in digital terminology, this open loop configuration of the op amp, which is analog in nature, is used to simulate the digital functions. That is, zero current means the state 0 and full current means the state 1. So switching between these two states in a switch with nothing in between, we have simulated the functioning of analog component as a digital component. So with this, we will stop today for the chapter on operational amplifiers, and so we have discussed the open loop configuration, which is used as a switch, but for this operational amplifier to be used or functioning as an amplifier, we will move to the closed loop configuration. Thank you, and looking forward to meeting you again.